Alright, so now we're going to do question 2. So you will notice that actually in the question, you might not know exactly what the numbers are or the elements are inside each set. So what I would like to advise you is to actually make a quick note of what are the possible elements inside the set as much as possible. For example, if they say x is a positive integer, you start from 1, 2, 3, 4, and you realize actually it goes on for until forever actually. So what you would do is just make a ... saying that, oh okay, at least I know the first few elements, and following that you know it's understood 5, 6, 7, 8, etc, etc. Next one, x is any prime number less than 16. So what is the smallest prime number actually that's less than 16? The very smallest prime number starts with 2, then we go to 3, 5, yes, what's next? 7, 11, 13, do we go on? No, okay, because we want a prime number that's less than 16, so we stop at 13. So at least in this set P, you can actually list out every single element. Okay, you can do this in pencil at the side as you're working. So now, this is a little bit tricky. What exactly does this mean? You realize that actually this is a simple inequality that you want to solve. So it's actually a simple inequality that looks like this. If I want to know exactly what a single x value is, actually what I do is I take 12 and I divide it by the 2. So I'll get 6. So in other words, you're actually looking for a set where x is any element that is bigger than 6. So once again, you do a quick listing. What are some numbers that are bigger than 6? But, or I mean just any number that's bigger than 6. So you realize you start from 7, not 6, 8, 9, 10, so on and so forth. Now, why do I only include integers? Yes, because actually the universal set only wants positive integers. So I don't have 7.5, 8.5, so on and so forth. There'll be too many numbers. So, see, before I even do the question, I actually list out as much information as I can. Okay, so now, let's do the first part. List the elements of P intersect Q. So this is a set. So I'll start with my curly brackets. So now, intersection again means union, in common. Not union, in common. What do you commonly see inside set P and set Q? Yes, you have number 7. Actually, you have 11 that's not written out. And finally, 13. So you write them out. Starting for the smallest one, 7, 11, and then 13. Remember, ... means actually there are a lot of numbers here. Just that I was a bit lazy and I didn't list them all out. No worries, you can actually know that they're there just by listing it like this. So this is the answer for the first one. 7, 11, and 13. So now, B. They want the value of n q complement. Recall, what does this n mean? It really means the number of elements inside this set of q prime or q complement. So what exactly is inside q complement? Similar to question 1, if q involves integers or positive integers already 7, 8, 9, 10, bigger than 6, all these. So what is inside q complement? Recall, q complement means everything that's not inside q but is still within the universal set. So actually it really just means any number that's less than 6, less than or equal to 6. So if we want numbers less than or equals to 6 and yet stay a positive integer to stay inside the universal set, we will have 1, 2, 3, still integers, 4, 5, and 6. So you see, you should list out the set of q complement so that when you take a look at it and answer the question, such as this, to know the number of elements inside q complement, it's really just a simple counting, and there you have it. 6 elements inside the set of q complement.